Peace be with you, integrated math and geometry students, as we look at some review here in light of our upcoming test later on this week. The first thing I'd like to go over with you is a set of converses or theorems concerning lines and transversals. So if you look at what we've got here, we've got two lines cut by a transversal. I'm going to call it T. And I'm sure you're very familiar with this, but I'm going to go through it with you again. What one theorem says, or one converse says, if two lines are cut by a transversal rather, such that corresponding angles are congruent. So if angles 2 and angles 6 are congruent, then the lines are parallel. Okay, that's one. Again, that's called the corresponding angles converse. So that's one, corresponding angles converse. And it's good that you know what corresponding angles are. Another one says that if two lines are cut by a transversal such that alternate interior angles, those would be angles 4 and angle 6, and they're interior because this region, as you might remember, between the lines M and N, this is the interior region right in here. The exterior would be on the outside here, or over here. So getting back to this, if two lines are cut by a transversal such that alternate interior angles are congruent, then the lines would be parallel. This arrow here on the lines mean that the lines are parallel. This one would be the alternate interior angles converse. Here are two others. Number 3, two lines are cut by a transversal such that alternate exterior angles, I'm sure you know what these are, angles 1 and 8, or it could be angles 2 and 7, but now I'm just going to focus on one pair. Angles 1 and 8 are congruent, then the lines would be parallel. This would be the alternate exterior angles converse. And finally, if two lines are cut by a transversal such that, and this is the one that you have to be very careful with because it's different here, angles 3 and 6, these would be same side interior angles because they're on the same side of the transversal. They're on the interior, same side supplementary. Take those S's to remind you. The same side interior angles are supplementary. Just write this down. Angles 3 and 6 are not congruent now, but supplementary. Then the two lines would be parallel, and this one would be called the same side or the book called it the consecutive interior angles. Angles converse. So those are the 4 ways of proving that lines are parallel. On the next page, I'm going to take you into proving a theorem This one is fairly easy. I know some people are leery of proofs and they don't like proofs, but they can be very, very easy, and I'm sure you're getting to see that right now. Now here's what we're going to prove: that if two lines are cut by a transversal so that alternate interior angles are congruent, specifically here angles 4 and 5, then the lines are parallel. So here we're going to be given that angles 4 and 5 are congruent, and we want to prove that the lines R and S are parallel. This will go very, very quickly. Let's set up our two columns here for statements and reasons. One more. Let's put the statements here. Reasons over here. You know very well how we start. We're going to start with the given. Angle 4 is congruent to angle 5. The reason for that is it's given. Statement number 2, though, is not given. And I should have marked this to show you up front something that you already know, that angles 1 and 4 are congruent, right? So we could say angle 4 is congruent to angle 1. I can just hear everybody shouting, I know the reason, I know the reason. Those are vertical angles. Vertical angle, you could say vertical angle are congruent, or you could say vertical angles theorem. And now taking these two together, we are going to do something that is becoming very, very classic, very, very normal. It's very consistent. And I'm going to say if 1 is congruent to 4 and 4 is congruent to 5, then what? And I'm sure you're saying it before me that 1 and 5 must be congruent to each other. Angles 1 going to be congruent to angle 5. And what would be the reason for that? Transitive property. And finally, here we've got corresponding angles congruent. And there is a postulate that governs this. And if two lines are cut by a transversal, and corresponding angles are congruent, then the lines must be parallel. So, since corresponding angles are congruent here, we can quickly say, oh, the lines related to those, namely lines R and S, are parallel. And you could just write the reason is corresponding angles this is a postulate. Okay, so that will take care of that. And finally, I'd like to go over something which is familiar to the integrated math people, but maybe not so much now to the geometry people, and that is the graphing of lines. Graphing of lines. You will remember y equals mx plus b is the slope-intercept form of the equation of a line. Slope-intercept form of the equation of a line. Why? Because the number before the x is the slope, In this case, it would be the 2/3, and the y-intercept would be the 3. So what is this again? Well, the slope is a measure of the rise over the run, and the y-intercept, listen carefully, is the y value when x is 0. So if x were 0, here we'd say 0 times 2/3 would be nothing right here, and y would be 3. Okay? So we can use this form very, very effectively to graph, and I want to show it to you right now. If x is 0, and this term right here would be 0 because that would be 2/3 times 0, then y would be 3. So one ready-made point would be 0, 3. So you can always use the y-intercept to start and just say, oh, this is one point right here. 1, 2, 3. That's one point. And then you use the slope to get a second point and you're done. Slope, the rise over the run. This will be from here now. We're going to rise 2, 1, 2, and run 3. 1, 2, 3. That gives us the second point. And a line connecting these points would be our line. This would be the graph y equals 2/3 x plus 3. Let's do another one. This one is not so simple because it's not in y equal to form, but we can put it in y equal to form by doing this. So what we're given, 3x minus y equals 4. To get it in y equal to form, we want to keep the y by itself. So what I'm going to do is I'm going to subtract the 3x from both sides. When I do, let me drop it down here. I'm going to get negative y, because the 3x should be gone from that side, is equal to negative 3x on the right plus 4. All I need to do now is to divide both sides by negative 1. Let's say we do it by negative 1 like this. So we get negative divided by negative. 1 is understood here. We have y is equal to negative 3x divided by negative 1 would be positive 3x. Positive 4 divided by negative 1 would be negative 4. So now we've got it in slope-intercept form again, y equals mx plus b form. And this will be our slope. With a slope of 3, that's the same as 3 over 1. So the rise would be 3 and the run 1. The y-intercept now is different. It's a negative 4. So what to do? We start with negative 4. Always start with the y-intercept. That would be our point here, because when x is 0, this is 0, and y would be negative 4. So we have this ready-made point here, negative 4. And from here, we're going to use the slope, rise 3, run 1. 1, 2, 3, run 1 to about here. Join these 2 points, and we have the graph of our line. Alright? I trust that will be very helpful to you, and may God just open up our understanding and inspire us, even as Jesus did when the two men were very, very confused. They did not fully understand what happened with Jesus. They thought he was still dead, but after he got up from the dead, he spoke to them and he shared the scriptures with them, and they understood very well that he was alive because he has defeated death on behalf of all of us. So replay this, take some notes on it, make sure you get it and you're ready for this upcoming test. All right? God bless you.